Hello, this is Charlene. We are going to be looking at simplifying radicals today. We have two different cases. We have a case 1 where we have perfect squares, and we have case 2, which is where we have non-perfect squares. So we're going to look at the difference between the two. We have on the left side the square root of 49. Well, the square root of 49 can be broken down into two factors, 7 times 7. 7 times 7 equals 49, and because there are only two factors and they are exactly the same, that is what is known as a perfect square. So the square root of 49 is simply equal to the 7, which represents that pair of factors. So that is the answer to the first one. That's a perfect square. Okay, so let's look over here at case number 2. Case number 2 is the square root of 112. Well, we can break that down into some factors. We can do 2 times 56, and we cannot take the square root of a 56 not evenly, so let's break it down some more. So let's say 2 times 2 times 28. How about that? So does that make sense that we have 2 times 2 times 28 would give us back the 112 if we multiply all those numbers together. So all three of those numbers are factors of 112. But let's break it down just a little bit more. So let's say that is equal to 2 times 2 times 4 times 7. So 4 times 7 equals the 28. So at that point, we still need to recognize the fact that if we multiply 2 times 2 times 4 times 7, it would give us back the 112. So at that point, let's kind of evaluate our factor pairs. We can see that this set of 2's is a perfect square because 2 times 2 is 4, square root of 4 is 2. So that means that one of those 2's can come out to represent that pair. And we also understand that the square root of the 4 is also a 2, so we can pull a 2 out to represent that 4. But the 7, we cannot take the square root of a 7. It is a prime number, so it must remain inside the radical house. So like I said, let's go back and see what we're pulling out. We're pulling out a 2 to represent the first set of 2's. We're going to pull a 2 out to represent the square root of the 4, but the 7 must stay in the house because we cannot take the square root of it nicely and neatly. So now we're going to put our 2's back together. So when we put our 2's back together, it's 4. 2 times 2 is 4, and that's times the radical of 7, or the square root of 7. So this is going to be the final simplification of the square root of 112. So this is how we're going to deal with non-perfect squares. We're going to break it down into factor pairs until we find some sets of perfect squares. The 2 times 2 is a perfect square, the 4 is a perfect square, but the 7 is not. It must remain in the house. Hopefully that helps you think about the process. Come back real soon, click on the subscribe button, click on the like button, and have a great day.